In short, if we have all these parameters to be a, b, c, if the hypotenuse is c, and if the opposite is a, if the adjacent is b, so we can redefine those parameter also in terms of a, b, and c. So we can say that sine theta equals to a over c, and that means that cosec theta will be equals to c over a. And then if cos theta equals to b over c, so sec theta will be equals to c over b, and then tan theta equals to a over b, so that means cot theta will be equals to b over a. So you can define their values and find them. So as a form of summary, the six trigonometric functions defined from the right angle triangle is given the following formula. Sin theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, tan theta is opposite over adjacent, cosec theta is hypotenuse over opposite, sec theta is hypotenuse over adjacent, and cot theta is adjacent over opposite. And then you can use these ratios as well to solve problems. So and mind you, remember that we derive the definition of cosecant, secant, and cotangent by taking the reciprocal of sine theta, cos theta, and tan theta respectively. So those parameters are also known as reciprocal functions because they are reciprocal of the fundamental ratios. Okay. So let's look at the example, guys. So find the values of the six trigonometric functions for each angle. Rationalize denominator where applicable. So these definitions are taken from what is known as a unit circle. Okay. So these are taken from a circular measure. Okay. Circle measure. So we are going to use this circle method. So we have a 3 comma 4. So a is 3 comma 4, right? Okay. So just let me draw the, so let's just draw what we have and define what we are trying to find there. Okay. So drawing the diagram, we will simply have this. So, we should draw a circle first and try to find what we need there. Circle. We use a plain circle kind of. Okay. So this is a circle. Well, let me use this circle. We are looking at the definition in A, right? A, and then the coordinate we have is 3 comma 4. So if you divide this circle into maybe 3, divide it normally, we have these parameters, and then if we draw the radius from any of the points, we have this form. Okay, so this is what we have. We have theta here. This is the radius. Okay, so this x is, so this can be given as x, y, and then you know this is x and this is y, right? So this is x, so this place will be equals to 3 and this place will be equals to 4, and then of course we have our triangle now. So bringing out the triangle, we simply have this definition. So this is theta, 4, 3, and r. So we need to use a Pythagoras theorem now to find the value of r. So apply Pythagoras theorem. So by Pythagoras theorem, we have r squared equals to 4 squared plus 3 squared, which is 16, plus 9, which is 25. So if we take the square root of both sides, we have r equals to 25. So r cannot be negative, so r equals to 5. Okay, so we have now that r equals to 5. So this is what we have, and then we can start defining the function. Therefore, sine theta equals to opposite. So you know your opposite now, so this is opposite this is hypotenuse, and this is adjacent. So that sine theta equal to opposite over hypotenuse, that is 4 over 5. And then from there we have cosec theta, that will be 5 over 4. And then we have cos theta, which is 3 over 5. So that from there we have the other one. Okay, sorry about that, let me make it straight. So from there we have sec theta equals to 5 over 3. We have tan theta, which is equals to opposite over adjacent, 4 over 3. And then we have cot theta, which is 3 over 4. So these are the 6 trigonometric ratios. So this is how you define values of angles, trigonometric function when you are given coordinate of a circle. Okay, so we'll just briefly take the second one, 1 comma root 3. So I'm supposed to give you that as an example, but let's just take it again. 1 comma root 3. So we need to draw our circle again. So this is 1 comma root 3. Okay, remember the triangle take its root from the circle. Okay, so if you draw it, this is the arm, the hypotenuse is always the radius of the circle. Okay, so this is theta, this is y-axis, which is root 3, this is x-axis, which is 1, and this is the radius. So we apply Pythagoras theorem again to find radius. R squared equals to 1 squared plus square root of 3 squared. So that will be 1 plus 3, which is equals to 4. So R equals to square root of 4, which implies that R equals to 2. So if we erase the R we have here and put 2, we have our right angle triangle complete. And then of course, you know, this is hypotenuse, this is opposite, and this is adjacent. So finding our trigonometric ratios now, we basically take our values respectively. So it then implies that sine theta equals to root 3 over 2, cos theta equals to 1 over 2, tan theta equals to root 3 over 1, which is equals to root 3. And then we have cosec theta, that will be 2 over root 3. If you turn, we are asked to rationalize, so we cannot leave it like this. So we rationalize the denominator by multiplying numerator and denominator by root 3, and that will be 2 root 3. So that will be 2 root 3 all over 3. Okay? And then we have sec theta equals to 2 over 1, which is 2. So we have cot theta. Cot theta will be 1 over root 3. Again, we rationalize the denominator, and that will be root 3 over 3. So these are the values we have for the 3 trigonometric ratios. So this is how to apply that. Example 2. Evaluate the 6 trigonometric functions at each real number. So we are taking these values. So we have the real number, we have t, we have the angle theta. We want to find the 6 trigonometric function that we are going to have here. So here, when we have the angle, how do we find the value of the element? Okay, so that is our concern here. How do we find those values when we have the number? So remember where we have the diagram where we started. So I'm going to show you the diagram now where we can take the value. So A, we have t equals to pi over 6, right? If you remember, if you convert this one to degree, we have times 180 over pi. So pi here 1, 6 here 30 degree. Okay, so this is simply 30 degree. So if we go back to our circle, let's quickly go back to our circle where we saw the definition of a circle. You can see 60 degree here, 60 degrees here. Okay, and the value of 60 degree, okay, it's actually not given, so we are just going to use the value. So let me just give you the value since it is not given. So the value we have here would be, where are we? So this is where we are. So this is 30 degrees. So the angle we have will be 30-degree angle. And then we are meant to find the values. So this angle is 30 degree, okay? And this is x, this is y. So the what we need now is how to find the value of y. So let's check how we can find y instantly. Or we can use our calculator still. So let's use calculator. So therefore we have this is hypotenuse. We don't know that. We don't know anything about the hypotenuse. So let's just use calculator. So sine 30 degree. Using calculator, what's sine 30? Sine 30 degree is 1 over 2. So that means this place is 2. Okay, 1 over 2. So this is 2, this is 1. So if we use Pythagoras theorem now, we can derive the other one, right? So cosec 30 will be equal to 2 over 1, which is 2, okay? And then by Pythagoras theorem, we have x equals to 2 squared minus 1 squared. So x equals to 4 minus 1, that is x squared, which is equals to 3. So x equals to square root of 3. Okay, so that means the base here is root 3, so that we can have that cos theta equals to root 3 over 2, and then cosec sec theta control y. So we have sec theta equals to 2 over root 3. So we can't leave the answer like that. We rationalize the denominator. So that will be 2 root 3 over 3, and we have cot theta, tan theta first, tan theta, which is 1 over root 3. Rationalizing, we have root 3, and that is root 3 over root 3 over 3, okay? So that cot theta will be equals to 3 over root 3, and then you rationalize again over this, so that will be 3 root 3 all over 3. So 3 goes in 3, we have 3. And these are the 6 trigonometric ratio of that angle. So this is what you do when you are given this kind of special angle. So you're